All right. Good afternoon, everybody. I hope you're all not sleepy. We'll wake you up, nevertheless. That's the whole point of this. I'm always excited for this session because this is when, a little less conversation, a little more observation satisfy me. This is the one that satisfies me because we can showcase all the stuff that we talk about, we all get up on stage and wax eloquent about how we have built the platform. Rubber meets the road here. And so we will give you a sense of, correlate this to what you heard in the morning in terms of why we made certain technology decisions and how we have basically brought that to the fore so that you may not have to do all the heavy lifting the platform will do. You will see the platform in action. And to help me with that, my partners in crime here, Perry and Matt Carabine. Perry's Perry Krug, who has been a co-conspirator with me on many occasions. So we will kick this off with a demonstration of what all you can achieve in this platform. Not everything, but most of it. With that, Perry, what you got in store for me today?
Thank you, Ravi. It's great to be here. This is my favorite part. It's your favorite part. It's Peter's favorite part. It's all of our favorite part. Over the next 30 minutes or so, we're going to go on a journey of digital transformation, try to show as much of the Couchbase platform in action as we can. And we're going to be giving all of you $500. Woo! These are virtual dollars. But nevertheless, I hope you spend them wisely. All right, let's get started. So here we've built a very simple stock trading application. You can see a list of companies, some real, some fictional. All of the numbers, all the dollar values are in fact made up. So if you see,
it's a parallel universe.
See Amazon at only 1,500, don't go calling your broker and placing a bunch of orders, all right? This demo is live. This application is live. The cluster is live. In order to make this truly live, we need data. We need data from us. We need data from you. And so what I'm going to ask you all to do is take out your phones, your laptops, your tablets, and navigate to this URL. I'll put it back up in a second. And start interacting with our system. I'll show you how.
So Perry, all this data is sitting in Couchbase, right? Just full disclosure.
Exactly. This is all running on top of Couchbase. In other applications, in more large enterprises, you might have data coming in from Spark and Kafka and other systems. In this case, we're using a load generator and our users out there. So I'll give you an example. If you were to enter your username, we're going to be maybe giving away a prize for the best investor at the end. I'll put it back up in a second. We're going to be rewarding our best investor at the end of the day. So give us something that we can identify you by. Pretty easy, whether you're on your phone or browser. Choose 5 or so stocks. The $500 will be evenly distributed against them. I got 3. Let's do a little bit of this one and some alphabet, and then just click submit once I get there, and the order is submitted. So I'll put this back up, and now please go ahead and start generating some orders for us.
Please do place your orders for your favorite stocks. But while you're doing it, let me ask Perry some troubling questions here. So Perry, talk to me about what this application is built on, what we have done to stand this up.
Yeah, it's a fairly simple application, but it's written in Python using our our native Python SDK, using the Twisted framework, which is nicely all asynchronous and helps really exploit the power, the performance, the distributed nature of Couchbase.
Fantastic.
Hopefully you've all had a chance to write down this very long URL and get in and place some orders. Let's take a look at what those are doing. Please feel free to place as many. Vote early, vote often. And we should see some of those starting to come in. Here we are. George Soros. Placing some key purchases.
He's diversified, looks like, huh? No more silver stocks.
There we are. Some more coming in. Mr. Buffett.
Woo. Read-only investor.
Stop refreshing. Mr. Buffett. Pulling up the stops, Mr. Henry over there, placing some strategic orders. Ooh. Mr. Banana, Ali, George again. All right, so we've got some live orders coming in. These are all coming from you guys out there. There's mine coming up. Matt, can you talk to us a little bit and show us what the back end of this system looks like?
Sure, Perry. So in the back end, this cluster's running Couchbase Server 5.5. So what I've just brought up here is a visualization of our cluster. So here we have 3 nodes, 3 data nodes, a query node, all running in Google's Compute Cloud. And underneath, you can see some bubbles. And each of these bubbles is an interaction.
Interaction.
Yeah,
What do you guys mean by interaction?
Well, with all of these applications that we're building, there's a lot of activity that the users out there, that our users online are performing, right? They are logging in, they're entering their username, they're seeing the stock prices updated, they're browsing through lists of stocks, they're placing orders. All of those are the interactions that create the experience and the engagement with our application here.
So all the looks that they are doing before the booking.
Exactly.
All the look and the book are showing up here.
Exactly, and all of our users want these experiences, these engagements to be personalized. They have to have lightning fast response time. They have to be available all the time. There's no more opportunity to say, I'm sorry, this site is down for maintenance or crashing under peak load.
Fantastic.
Let's go and create some more load. Matt, can you generate some more simulated traffic? Get those.
I need to see more bubbles
moving?
here.
You should see the bubbles going, Perry.
They're going. There we are. There's a whole bunch more.
Now that looks like a serious website where you have millions of interactions happening. Before that was a little anemic. I mean, only we know that was anemic because we have customers who do 8 million ops per second kind of stuff. But this looks impressive, colorful enough to please our marketing department, I think. But lovely. These are the interactions that are going on here. And you have, 4 nodes, 3 nodes, and a query node, 3 data and 1 query going on there. So, life gets in the way. It's not always this hunky-dory. And so let's imagine a situation where things are not as optimal as you would like. What is the customer going to experience?
Very true. And this is all nice and fast, but the only thing worse than a slow website would be one that's unresponsive entirely. But as you said, things go wrong. Sometimes disks fill up. Sometimes the network goes down. Sometimes some clumsy administrator pulls the cable out on the wrong server.
Yeah, exactly.
Why don't we see what might happen? And I need to find some clumsy administrator I can. Hey, Matt.
There's the clumsy administrator for you.
This is going to be interesting. Why don't you play the? I know it's hard for you to play this role. Play the clumsy administrator.
For you, Perry, anything.
Thank you. Go into go into our Google Cloud platform where all of this is running on top of. I see we have some of our Couchbase nodes there. Let's pick one at random. You've got 3
I already
selected.
have 3 ticks,
we might as well
we
stay
may
with
as well
that
do
one.
3.
And kill that. So
Let's delete it, Perry.
let's
Let's go all the way.
Oh, going bold. All right.
Whoa, you guys are taking a chance right on stage.
It's Couchbase, Ravi. We got this. All right.
You guys got this.
So
Okay.
the node is going to go away. There it is. The cluster detects that it's down. You see some of those transactions, some of those interactions are waiting for that to go through. The rest are working fine because the rest of the cluster is unaffected.
This is the time when management goes for a panic, right?
Not necessarily. So we automatically detected that node was down, did an automatic failover, and you see everything is continuing back as if nothing happened.
Okay. But there's still that X over there.
Well, the node is down. We haven't
Okay,
fixed
you haven't really
anything
fixed
yet.
it yet.
We've just failed over
Okay.
and let the rest of the cluster handle the load.
Okay. That's what's basically, we're getting the capacities now handled by the other 2 data nodes.
Exactly.
While this one is down, and it's down, but the interactions haven't stopped.
They're continuing.
The customer is not actually. So while all this happening, what's happening on the application front from the standpoint of the end user? What is really impressive here is that all these millions of transactions we take, irrespective of what's happening in the back end. This is the database that is built for failures, as I call it. This is a situation that can happen in a data center where a rack fails, a network switch in a rack fails kind of thing. Then we have this rack and zone awareness capability, which makes sure that another node, another rack takes over this. You can place the data in that manner. Or if you are doing an availability zones in any of the cloud deployments, then if a availability zone US West goes down, your data will still be served from US East perhaps. So that's how you can set up your cluster in such a fashion that the data is always available no matter what sort of failure happens. A rack fails, availability zone fails, a node fails. Any of these failures is actually handled. Or you can even take a node out for maintenance purposes and put it back in, right? All these interactions will continue from your application perspective. 5 nines availability is guaranteed no matter We'll take it one step further eventually when we talk about mobile, but this is where we are right now. This is what inspires me, really. If you wanted this in our traditional databases, you literally needed someone, not so clumsy DBA, carrying a pager and walking around to make sure that if something happens, rush back and fix things and stuff like that. Here, the system takes care of itself.
Yep. And we have more.
And we have more?
And we have more.
You have more?
So I think now would be nice to maybe explore the rest of the platform. We've looked at kind of simple access. We've looked at performance and high availability.
Yes.
But now that we've gotten all this data in from our users, we might want to start asking some questions of it. We might want to know how all of our investments are doing.
Yep.
We might want to know which stocks are most popular. We
Who's
might
the
want
best
to know
investor?
what time our users are in New York are accessing the system, and that might be a good time to place some ads in front of them. All of these things. And there's different ways of asking these questions. You might decide to pull up some other piece of technology, move your data over to it. You might have to write some complicated application code. But
no ETL, you're saying?
You might have to ETL it, but not within Couchbase, right?
Got it.
And we have a built-in query workbench that lets you explore the data, optimize your queries, and then build that into your application. So maybe let's take a look at that. Matt,
Go for it. I won't ask you troubling questions.
Can you go into the query workbench?
So here I'm just going to go to the Couchbase server UI. We can see we've got our 4 nodes. The one we failed over earlier is still sitting around, so I'm just going to quickly clean that up. It'd be really nice if I didn't have to bother doing that, though.
Just look at that. That's for all the database administrators to do these days. Just click a button and go grab coffee or...
So what I want to do now is get some insight into this data. So if I take a look, let's find all the companies where, I don't know, technology companies, Perry?
Let's just see what we can see in technology.
Okay, so it's quite simple. Select company from CBSE. CBSE is our bucket where sector equals HDMI pulling out. Where sector equals technology.
Oh, great! And there we see the list of companies.
Apple, ACM. But Perry, this looks a lot like the good old SQL that we all grew up in.
You're right. It does look a lot like SQL, and this is in Couchbase. This is our nickel query language that you alluded to earlier. It looks like SQL. It looks like SQL on purpose, right?
Yep.
We know that everybody out there is familiar with SQL. They've spent years and years in university learning SQL, learning SQL, and so we've built our query language to look as much as possible like SQL. So all of that same select star or select field from a bucket with some predicate, and you can do order by and grouping on that. The challenge, though, is we have JSON underneath.
Yep.
And so SQL doesn't know how to operate on all of the types of JSON that you might have. Nested objects, arrays of nested objects, arrays of nested arrays of nested objects of nested arrays.
Recursive, I get it. Yeah.
And even difference in schemas, even situations where some data is different than another. You have no way of expressing that within SQL, and with Nickel you do.
Okay. Can you show something?
Yeah, let's take a look at something a little more complicated. If we wanted to, I don't know, what would you like to look at that's more complicated?
Well, in true Blue Peter style, I don't know if that reference translates over here. Here's one I made earlier. So what we want to do is find out what's the most popular stock. And you can see the unnest that you mentioned earlier for querying the nested JSON objects. But actually, you might notice as well this join. We're basically joining 2 documents together where the symbol is the same. So we're taking an order from the user and the stock document and performing a join there.
Lovely.
So if we execute this.
And you're grouping and ordering and limiting it to 5. So let's see the top 5. Ooh,
there we go. We're getting
Apple
a
is very
lot of
popular.
Apple purchases. That's good. A lot of Alphabet, some Netflix in there.
Look at the beautiful display of it. Fantastic timing. So look at that. It's got a nice table format to it. That's not how the data actually looks. Nice.
Neither's that.
So could you, even better.
Don't
Can
move.
we click on the JSON? Yeah.
Okay.
Stay away from it. It doesn't like you. So that's the JSON, how the raw data is produced, but just a click of a tab and you can see it in a nice tabular form that we're all used to in an Excel sort of a format. Look here. Fantastic. And also there are other stuff out there, a query plan and plan text and everything is there for you to go observe and see how the query is actually operating. And if you want to further optimize, all those capabilities built into this workbench. What's happening, can we look at it from the application perspective?
Sure, so we could use this query UI, query workbench to practice our queries, to get a feel, explore the data, get a feel for how we want to structure that, and then just embed that query in our application. So if we go back and we go and take a look at, we were looking at the top stocks, let's look at how those stocks are performing. We can see right within the data as it's been generated live, we're seeing some of the best and the worst performing stocks there.
Fantastic. So typically users went to our application and picked those stocks from there, right? That's how they're basically able to create these stocks, and they're placing their orders and stuff like that. But you went here and you clicked on these stocks. That looks a little, list view and form view kind of stuff that we used to have classic relational days. That's not how people behave these days, Perry. I mean, you search for something and you add it. It's the world of Google and beyond.
I thought you might ask for something like that.
Yeah.
And actually, we're going to see it's pretty easy to do in Couchbase. And before, with just kind of structured query access or key value, you would have to ETL. You'd have to extract it to some other system, maybe a search engine or other technology. You'd have to write your application to manage the consistency between those two. You'd have to learn different APIs, different programming models, and you'd have to make multiple queries and merge those back into your application. But Matt, why don't we go and take a look at what that looks like to build into Couchbase?
Yeah, of course, Perry. So what I'm going to show you here is how you add a new node to a cluster. So any node that has Couchbase Server installed can actually run any of the services. There's not a separate eventing package. There's not a separate query package. All the nodes are the same. So first thing I need to do is tell the node about the cluster it's joining. So first the host name, then the credentials. Then I just need to select the services, in this case search, and join. Then once that's done, you can see it's now in the cluster, and to bring the search capability in, all we need to do is rebalance. So just a couple of clicks, and there we go, we can search. But actually, we can't quite search yet. Why don't we create an index? So what I'm going to do is create an English index. Maybe some point down the line, you want to localize our stock exchange. So what we can do is we can select, okay, what fields we want to index. We can select what documents we want to index. So we can select things like the language you want to analyze with. So if I do stock document and store in dynamic fields, and that gives us the ability to see highlights when we search for things. So just going to wait for that to finish.
Okay, there it's done, 100%.
So what should we search for, Perry?
Let's search for Inc. Incorporated, Inc. something, see what we have in there. Oh, there's some of those companies coming through.
So we got eBix Inc. here, JD.com Inc. But actually, again, what use is this? We're not going to ask our users to log into the Couchbase Server UI and type in their stocks. It's not,
Thank you for pointing that out, Matt.
So if we go back to the original page, we can see, as if by magic, a brand new search bar. So let's search something. Corporation.
Matt, you misspelled corporation. That's not how you spell corporation.
He's a Brit.
But actually, okay, I see. It's okay because the full text search service supports stemming and tokenization and natural language, and so it knew what we meant, just like Google did.
It's got autocorrection and all that stuff just for us typing impaired people. So fantastic. So now you're able to search, and you have added search capability, just like Matt would say, 3 clicks, and there you are.
Just like that.
The search box wasn't there. Now you've added that, and you're able to sort of search for texts, which is part of the company names and stuff, and you're able to pick the stocks and show this out here. So this is a major addition in terms of how you can interact with the database. As in, so far, the magic here is that the same JSON document was looked at as a ordered element, as in it's got the schema and the data. And so the query looks inside the schema and picks the data and does the ordered processing on it. That's how Nickel works on it. With full text search, it takes the other interpretation of it. The entire JSON is also human readable, so it treats it like a Word document. And it actually is looking for text patterns in it. It's basically doing what we call as tokenizing, lexical parsing, stemming, whole bunch of stuff, and it creates what is called as an inverted index. So it's looking at the JSON as a schema-less Word document, if you will, right? Human-readable document, and it is looking for these patterns in it. So corporation could be anywhere. It doesn't have to be in the name. It could be in the description. It could be in a summary or wherever it is, and it'll look for that and display that here. All you have to do is when you display that, you say what is the end result you want, which is a stock symbol, and you can display that stuff here. So you're doing both data processing, query processing on it. At the same time, you're doing the information processing on it, which looks beyond just what that data is specificity. It's got fuzzy logic and other capabilities in it. So that's the power all in one place, in one index. Typically, like Perry was mentioning, what you would do is take this database, create your connectors or whatever, shove this data into your own favorite search, and then it'll start searching over there, whereas the data could have changed here. Now you have all your consistency problems and other stuff, which is not what you get here, because the moment the data went in, it was instantaneously sort of went through our lexical pipeline and then created that inverted index. So that's the power here. Thanks for bringing that to life, guys. Now, what else can we do here? You're not going to just leave us here, are you?
Well, no. I mean, we talked about the performance, and we talked about the high availability. We talked about the flexible access patterns. But that's just on the data that we have in there already. I think maybe we'd like to see what it would be to personalize this for our users, or add some context to it, right?
Sure.
So let's imagine that this application has been running for a few months now. We've built out our user base. We've got a lot of orders and data in there, and we want to ask a question about geographic performance. We want to see where our users are geographically. Now, I mean, I know, we know it's easy to build an application to do that. We even built one here. We can just click on this geographic performance page, and this is what we built.
But I don't see anything that says unknown.
Well, yeah, so the problem is we...
Translate this, please.
I don't know, is it in Polish?
This is what happens when you have artificial intelligence working. Sorry.
So when we were gathering these orders, when users were using the application, we weren't asking for their geography. We didn't know that we wanted it at the time. We could, but then we'd have to go back and update everything. But it wasn't in the schema back then, right? And now we want to add it too. So we built the application to be able to support that. And all it knows is there is no geographic data in there, so everything is unknown. But Matt, can we now go back into the Couchbase and maybe start changing some of that data and see what happens?
Yeah, so to do that, I'm just going to go back to the Couchbase server UI.
Swipe to the other.
And first I want to swipe so you can see them side by side. So we've gone back to the Couchbase server UI, and what I want to do is just update one of our orders. So Ali, I know Ali, so it's easy for me to decide what geo she's in. So you can see this JSON document, which is the underlying structure that we mentioned earlier. And we can put whatever we want in this. So we're just going to put geo USA and save it. And then as if by magic, there it is.
Oh, there. Now see, we can see it in the app. So we've just changed one piece of data.
Okay. That I can understand, one piece of data. This is where we basically want to talk about how you can have multiple versions of the schema and how the query language actually can accommodate to that. Yeah, I finally can get this one right. Yep. But in application, that's not how you go about changing just one data, right? Is there a way that for every user you can categorize them into some geos?
Well, let's look at like slowly migrating the schema over, and if we started capturing it from our users, or we can go and change the data that's in there. Matt?
Yeah, so we saw earlier the query capability. And what we did earlier was we selected a document from a field. But actually, we can use this to modify documents. So again, one I prepared earlier, we're going to set the geography to USA of everybody whose name begins with M or less in the alphabet. So if we run this...
A to L, that means, right?
A to L, indeed.
A to L,
Just trying to be helpful.
So we've got more orders now in the US geography. Why don't you go and finish it off?
Yep.
That is M to Z for
those of you playing at home.
N to Z, Ravi.
Oh. Tomato.
There we go. And so now we have those in the EU. We have those orders a lot of orders in the M to Z.
Whoa, keep scrolling. Okay.
All those users.
Thank you very much.
That's okay. We've had a lot of orders today. That's good.
All right. Look at this. This is an engagement system that's really engaged with the users. I won't take offense if all of you are looking down and doing something here. I know
You're engaging.
You're
they're
actually
engaged.
placing. Fantastic. So what we have actually shown you is what we call a schema evolution. That's what Perry here so gently pointed out, is that there are two scenarios. One is that you have deployed an application. Now you want to change the application. What you literally did was change the application on the fly here, and the application still works. It basically added the geo, and now you can see by the geo. Like this, you can do a lot more other stuff. What you've really done is, when you went and changed that document, you basically added the geo capability into that one. That is a extension of the schema. Now, there is a situation that you have extended the schema, but still there are there are users who could be actually coming in without the geo information. So the query language has the capability to adjust to that as well. It's got the syntax in there which talks about is missing or is null, because lack of a certain field does not mean it is not there. It's only not there for that record. This is what schema flexibility actually buys you. It's not going to barf on you and say that, how come you have this table without this? I can insert into that, or I can't make change to that. It'll accommodate to whatever the schema that is coming here. That's the brilliance of what the query language really brings into the picture here. Even though it looks like a standard SQL, it's doing a lot more magic and operates on top of that. Fantastic, Perry. This is a good illustration of how you can extend the application after you have having deployed. Now, of course, we can't leave our mobile users on the lurch, can we?
No, I mean, we've got all of these users out here just accessing a browser-based application. Even if you're on your phone, you have to be connected to the internet.
Yes, but this is New York, and there are people who could be in, in their tubes and all that places and stuff like that.
They could be in the subway here.
Subway here, yeah. Sorry, tube is. He changed me with this Z. So I know what you mean. So what could we do for such users?
So we've got you covered, even underground. And without making any changes to this application, we can build a new mobile application, and we can synchronize some of the data down to it. So let's take a look. If I swipe over here. Thank you. If I swipe over there, and I've got my phone here, and so this is my actual phone, and this is an actual application live. So I hope my mom doesn't text me at the moment.
Or your mother-in-law.
We should see the prices be the same. If we try to pull one up here, which one can I look for that we prove it to you?
Maybe Apple?
Amazon was there. It's all A's here.
Thank you.
No? Akamai maybe? Alphabet.
There we go.
There.
Anyway, you see the prices are the same, and as they update on the server, they update on the mobile device. So this is synchronizing from the database that the application is running onto down to the database that's running on the device, and without any extra web service calls or REST APIs. All I have to do is access the data that's local on this
Prove
device.
it to me that it is not a REST API call.
All right. Well, why don't we pretend to be underground, maybe
subway.
up in the air, maybe in the back of a warehouse somewhere. If I go into airplane mode, simulating being offline, and now we're offline, we should see the prices continue to update on the server, on the web application, and they're not updating here anymore because I'm offline.
Alphabet is 734.15 on the web. Connected, disconnected is 743 only, right?
Yep. No, it's
place?
updating there,
Okay.
and not over here. So that's what we want. And the nice thing about having a database on my device is all the data that I had here is still available. So I can scroll through it. That's easy. I can categorize things the same way using nickel queries right on the device. So I can choose this again and filter down. And I can even now have full text search on here. So if I type for that, and I can see that we have all of those same corporations there, and I can even click and get some of the information about one of these companies.
Base Corporation. I like the name. Now, all this is good, Perry, but you know what happens. You deploy these things, millions of devices working, but then on the server side, you want to go and change applications, or you want to sort of have guys like me walk in and say, I have new requirements kind of stuff. So now,
so let's do the same thing that we did. Matt, do you want to go and maybe add some records to, or add some fields to some of the data?
Sure. So again, you must be getting very familiar with this by now. Going back to the Couchbase server UI. And so what I'm going to do is find one of our stock documents. We have Base Corp up. I'm a big fan of Base Corp, so once I've refreshed this page.
With the Wi-Fi.
Yeah, Wi-Fi's letting us down. Where was the Ethernet? Here we go. Now it's loading. So what I'm basically going to do is go to the Documents tab in the UI and change one of the stock documents.
Whenever it shows up.
Let me go try the other one.
Yeah.
Is it a Wi-Fi thing?
Yeah.
Okay.
Okay.
Let's keep talking to cover for that thing.
Let's keep going on. We can come back to this when it loads up. So we've already shown that the stock price is updating there. We've shown that we have the data
Yes.
available on there. We could set this up to replicate back, so that if we make a change to the mobile device, it will synchronize back with the server.
So the way we could have actually seen this whole thing, which is what Matt is attempting to do, is that you actually can make this schema change on the server side, and you'll see that seamlessly happening, getting propagated all the way to the client and to the mobile side, without you ever having to make any change to your mobile application, by which I mean you don't have to change the application, get it approved and uploaded onto the App Store, and all that sort of lifecycle management of an application on the device goes away, because now the schema is treated as data, and the change to the schema automatically floats down to the mobile device, and you'll be able to make further changes or capture data on the device to the schema changes that have happened on the server. So that's the scenario that we were sort of going for here, to no fault of...
Well, Ravi, good news.
Good news.
We're back in business.
He's back in business. That's why we have two of these guys here. It's a fault-tolerant system. Hopefully.
Eventually.
Soon. Eventually. We'll
takes
be
a
eventually
village.
consistent. But actually, we are a very strongly consistent system, just so that you all understand in terms of the CP side of the equation. This is when I start doing my song and dance while these guys try to get the demo going. So I think, will we be able to proceed further, Perry, with this thing?
Let's continue on.
Okay, so what we basically sort of so far showcased you is a case of an application which sort of evolves, and that evolution actually makes it all the way to the device. That's how far we have basically gotten with this whole thing. We could also further show you other stuff provided IHG Connect. You got to go to Couchbase, I think. We live in an extremely connected world, and if the connection isn't there.
There we go. Back on Couchbase.
Something had to go wrong.
There we go.
go.
All right. Sorry about that.
Saved by the bell. I hope. Don't clap too soon.
No. Keep clapping. Keep
Yeah.
clapping. Keep clapping.
Gonna-
Yeah. If you believe, clap if you believe.
So what we're going to do, I'll just do it. What we're going to do is change one of these stock documents. So take the Base Corp stock. I believe in Base Corp. They're going to make it really big one day. And we're just going to change it. So what information do you want to know about a company that's publicly listed? I guess probably their CEO.
Yeah.
And Perry, I'm moving up in the world.
There you go.
Matt
Well done, Matt.
This is the power of a
Really
developer
good
these days. They can self-appoint themselves.
Okay. Well, we should see that.
So now we can look.
What's going on here?
It's
Wi-Fi.
still not working.
I eloquently talked
We're
about.
still offline on the device. We're still underground. So let's
You guys have
go
to create
back
drama
online.
for me.
Once we see the stock prices start to update again, start to flow in, there we go.
There.
If we click on that, and we can see the change.
Matt
that we,
Carabine is the
that we just
CEO.
made.
Did you see that schema change just float magically from the server down to the mobile device? This is the power. This has never been achieved before outside of our demos like this. But this is amazing what these guys showcase. What's happening magically in the back is like it's doing stuff like, of course, conflict resolution of data, security that it has to apply, which device, which user should see what data and what somebody cannot see, visibility rules and stuff like that. All this is handled by the sync gateway, which is in the back, and it pushes that change down to those devices, down to those profiles where they have the authorization to view this. So that's what we got to see. We extended the schema. No other change required. Is there any mobile backend as a service or any of those things?
No other components in the stack, just the Wi-Fi.
Just the data has to move. And so the data moved here in this case, and are we back in business?
It did, yeah.
Are we white
yeah,
screening?
It's okay.
Okay, that's fine.
That one's fine.
Lovely. This is the new world here.
So this was all the developer
capabilities. Fantastic. Now, how about while all this is happening, we know we got to be like the aircraft carrier, which is calm on the surface, but able to handle all the unsettling things in the back. So things could be going wrong. So how do we help our DevOps folks in terms of how we are managing this whole thing in the back?
Yeah, and maybe you've heard of things like containers and
I have heard of
Kubernetes
those things.
and OpenShift. So
yeah.
We've talked a little bit about today. We have just released the beta of our Couchbase autonomous operator for Kubernetes and OpenShift, and so we're gonna take a look at what that can provide now. Matt, you want to go over to that?
Yeah. So in a minute. So here you can see the UI of our Kubernetes cluster. Unfortunately, because the Wi-Fi dropped out, I just need to do one quick thing. And then hope it loads. We're back in business.
Okay, good. So the operator allows you in code to define a cluster, and then save that YAML file or through a UI configuration. And the operator will then spin up these nodes as it did here, cluster them together, and from there, Matt, why don't we need to put some data into this one, right?
Yeah, right.
It's empty right now.
It's empty right now. So what we're going to do is we want to move the data that we had in our original cluster into our new cluster. And the way we're going to do that is using Couchbase's cross data center replication feature, bit of a mouthful. And so what we're going to do, go to the XCCR tab, we tell the node about the new cluster, so new cluster, Kubernetes. Then we give it the host name, which I've conveniently written down here, and the credentials. So now this knows about our new cluster running in Kubernetes. So we should be able to then create the new cluster, and there we go. Now we're replicating.
Fantastic. Lovely. So what he just did was to set up a cluster in the cloud, and with one click of a button, move the data. And that's already migrated, right?
So we've migrated the few thousand items into this new bucket, now into our container-based cluster. Could be in a different cloud, could be in your own on-prem, could be back and forth. That's what the cross data center replication
Fantastic. So this is how enterprises can seamlessly, so to say, burst their capacity to the cloud by setting up a cluster in the cloud. Could be any one of the popular cloud providers, public. And you can just with one click of a button move the data from your on-prem to your on-cloud deployment. And with that, what you basically are getting is this ability to go from one cloud to the other as well, right? You can just cross data center replicate between one cloud to the other with the same click of a button. And
so the operator has deployed it, is now managing that, and the Couchbase operator, the autonomous operator, is also capable of auto scaling a cluster.
Yes.
So let's go and take a look. And we have that same setup that we had before, the 3 data nodes, 1 search, 1 index and query. Let's add another node to this. And it's just a simple matter of changing the configuration file, adding another, what are we adding? Another data node, another query node?
Well, we need another index query node to keep up with our new data.
And provide some high availability in there, absolutely. So save that and step back. And what the operator is doing now is it sees a configuration file has changed. It recognizes that change. It's spinning up a new container, a new Docker or OpenShift container. Once that's ready to go, we'll see it added to the cluster. And then the operator is doing all the work to make sure that it has provisioned the right disk, has added the right networking, knows about the cluster that it's trying to add, added into the cluster, and did a rebalance.
Beautiful.
You didn't touch those keys, right?
I don't touch it. Okay. That's what you guys got to say. Did you see that? I don't see that, light in your eyes. You really haven't believed it yet. What really happened out there was, all that happened was a Kubernetes, a node with the Kubernetes agent was there. Rest of the stuff was sort of magic from there. You just added that recruited it, added it into the cluster, rebalanced. That means more data. If you had 3 nodes, 1/3, 1/3, 1/3 was the data. It moved the data to become 1/4, 1/4, 1/4, 1/4, and magically within seconds, while we were just talking, it's now added more capacity for you to do the compute, right? Phenomenal. But life.
That's not all. The operator also
Yes.
supports auto-healing, self-healing.
Self-healing.
Yep. So we saw before when we took a node down and Matt had to manually go and clean
Hit the
it up.
rebalance,
Hit the
yeah.
rebalance,
Yep.
clean it up. So let's try this again
Really?
over in this world. Yeah, I think.
Is the Wi-Fi in good shape?
That's the least of our.
Anything
least of our
goes wrong,
concerns.
we'll blame it on the Wi-Fi, okay?
So we'll need to find ourselves another clumsy admin to make a
Yes.
mistake with one of the.
Trip over
Matt,
the wire.
Why don't you? Let's choose another Kubernetes node, one of the ones
okay.
that
You're
number
Because I'm having
5.
too much
yeah.
fun.
That's fine. You're gonna delete this one as well. All right.
Yep.
Whoa.
Well, it's,
Bold move. Could be career limiting.
click
Think about it.
delete, and if we go back, it's already down. That's how quickly the container is pulled away. The cluster is going to
Hey,
detect.
Perry, I think they're setting up the drinks, so I'm off.
You're off, but we need the administrator to. Are you're sure? You're sure
Yeah,
about
I'll catch you
this?
later, Perry.
All
Good
right,
luck.
all right.
Good luck.
Thank you, Matt, very much.
All right, the cluster
This
has.
is the database administrators we have now. Now we are left holding the bag up on the stage, but let's see.
So it's automatically failed it over,
Yeah.
right, as the same as before.
Yes.
And then now the operator is going to kick in. It has is adding a new one in as we speak. Wait till that's online, and is initiating the
Initiating
rebalance.
the rebalance.
All without Matt even being around.
While Matt is having his drink. So it recruited a new node, added to that. Once it detected the auto-detected the failure, it self-healed itself by bringing another node. All it had was that Kubernetes agent installed, and it brought it into the cluster, rebalancing the node so that it has got the extra capacity back so that the interactions continue as they are.
Yep.
If this isn't magic, I don't know what it is. So to the magicians of the world, please give it up.
Ravi, we've got one more surprise for you.
One more
One more
surprise?
surprise.
Oh my
So,
God, I don't know
if we
whether
go
I
back
can
to
take
the
it.
application that we had before, wherever it is, there we are.
All right.
So at the end of the session, we've had all of our users placing their orders. I think it's time to find and reward the best investor.
Totally.
The challenge here, though, is it's even more complicated now to find all of the orders that have been placed,
Yes.
link them all by investor,
Yes.
so do a join across those different documents, do a sum to see or do a calculation of the starting price of the stock with the
Ending
current
price of the stock,
it,
who
do a
made the most
sum,
money.
get all of that together, and so
Pretty
if we-
sophisticated query with a subquery and a join. And
Exactly. If we go here, we can see currently that Greg, making some very shrewd investments, has quadrupled or so his investment. We're not allowed to give away anything to our own
Sorry.
CFO, so we're going
Totally.
to go down to Joe W., who wins
a phenomenal bottle.
a phenomenal bottle of Mum's champagne.
Totally.
So Joe,
Champagne for
Joe
Joe.
is in contention with URS PKP, so you guys might have to share this bottle.
Sorry, just by $4?
I see. I hope it's not anyone actually from USA Today placing those orders, but you seem to have lost us a few $100. In that case, I have the finest bottle of our cheapest champagne we could find. So we'll put these on ice for you and hopefully share them with the reception later on. So
Fantastic.
thank you all very
Thanks
much.
for all of your participation. Thank you, Perry.
Thank you, Ravi.
Amazing job.
Thank you,
Thanks,
Matt,
Matt,
wherever you
you
are.
are with your drinks.